This is using trig substitution with x equals a sine theta. And it won't always just be a sine theta, but it's a trig sub with sine theta. And the way you can tell we're going to be using sine theta is with this. If we are subtracting with an x squared, so we have some number minus x squared, we're going to be using x equals a sine theta. And the reason is this. If we use the 1 minus sine squared theta equals cosine squared theta, then we can use that to modify it. So if we have a squared minus x squared, that's our starting expression. And we replace the x squared with an a squared sine squared theta, like this. This allows us to factor out an a squared. And then breaking that apart, we would get a squared. And then 1 minus sine squared theta is cosine squared theta, giving us a cosine theta. So we can turn our a minus x squared into an a cosine squared theta, cosine theta. So what you do is you start with that expression that has that situation going on. So there's our 16 minus t squared. And yes, you can always just go and go, okay, well my a here is 4, because it's the square root of 16. And so I'm going to be using t equals 4 sine theta, and then break it down that way. But this method will work every single time. What we're going to do is just substitute it with what we know it needs to be. This needs to be 16 sine squared theta, so that we can factor out a 16. Which would then give us 16 cosine squared theta. And then we take the square root and we get 4 cosine theta. So now we know that this is equal to this, which is sitting right here. And within that problem, you can see that our t squared here is 16 sine squared. That is our substitution. So by just actually replacing it, it's just basically rewriting it to make it look the way we want it to look, it tells us what we need. So that means our t squared is equal to 16 sine squared theta, which means t would have to be 4 sine theta using a square root. And anytime you do a substitution, we're replacing t with theta, in this case, t with a sine theta, then we have to find out what our dt represents as well. So we end up with that. Now it just becomes a bunch of substituting. So we can replace our t squared right here with that, and then we'll use pink. And then our dt becomes 4 cosine. So plugging all this in, we get 4 cosine theta d theta. And then our t squared is 16 sine squared theta. And our radical becomes 4 cosine theta. And that is our integral. So now it's just simplifying and integrating. So those will cancel. We can pull the 16 out. So we end up with 1 over 16 integral 1 over sine squared theta d theta. Now when we do these, the radical is going to be on the bottom or on the top, but it's usually in a fraction form. So after you do your sub, a lot of times you end up with a fraction. So your next step is to use any of your trig identities to convert it back to a non-fraction. So 1/16, we know that the reciprocal of sine theta is cosecant theta. So this would become cosecant squared theta. And that we know the integral of. That would be negative cotangent theta plus c. So what I'm going to do is put the 16th in front, since that's all we have. And then you may want to circle it and say, oh, we're done. No. Remember, this started with t. So we have to use that substitution just like before, and we have to plug it back in. Now, normally when you add u sub, it's easy to just substitute it. So you end up with a u, and you plug it in. With trig substitution, though, we have to use our t and our theta. And our theta is located inside of a sine. So we need to rewrite him and use our little triangle here to find everything. So we know that that's opposite over hypotenuse. So solving this using the Pythagorean theorem, what you're going to end up with is 16 minus t squared here inside the radical. And that should look familiar because that's where we started with. It all comes from our substitution as well. So now all you have to do is find the trig ratio that you need. So cotangent theta, well, cotangent theta is adjacent over opposite. So that would become the square root of 16 minus t squared over t. And then we just plug that back in. So we end up with negative, let's put that back in blue, negative, and then on the top of our fraction we have 16 minus t squared. And then on the bottom we have 16t, and then we put a plus c. And there you go. And these are the same steps that are going to work on every single problem. All we're going to be doing through these videos is changing the different substitutions. So we're going to be using sine, tangent, and secant based on what they're giving us as our binomial. So let's try another one that involves sine. All right, so you can see this one here has 9 minus x squared. So that's where we're going to start with our radical. And it's not always going to be in a radical. You're just looking for that binomial. But we know that we need to have 9 minus 9 sine squared theta, because when we factor out the 9, we get 1 minus sine squared theta, which we can then convert into 9 cosine squared theta. So we got to use that Pythagorean identity that gives us our perfect transformation. So that becomes 3 cosine theta. This again then tells us that our x squared here has to be 9 sine squared theta. So our x squared equals 9 sine squared theta, not sine times 2 theta, sine squared theta, which means x equals 3 sine theta, and then dx would equal 3 cosine theta d theta. So it all begins with just that whole 9 minus x squared. All right. So then we have our substitution that'll go in perfectly. So we know that x squared is this guy. We know our dx is this one. And we know our 3 cosine is that one. So all I have to do now is plug it all in. So we get 3 cosine theta. Didn't write it here. There we go. And then x squared is 9 sine squared theta. And then dx is 3 cosine theta d theta. Integral and simplify. So 3, 3, and 9 all cancel. We end up with cosine squared theta over sine squared theta integral d theta. And again, our goal is to get rid of that fraction. So we can convert this into cotangent squared and then convert that into secant squared theta minus 1. But I'm going to go with the standard. Let's just change our cosine into a sine. So this becomes 1 over sine squared theta minus 1. I'm going to actually write it as sine squared d theta. And then this becomes cosecant squared theta minus theta d theta. And that can be integrated. So we end up with negative cotangent theta minus, it's not theta, it's 1. See, I'm already ahead of myself. Theta plus c. I knew what it would become. All right, and then now we just go back and make our triangle and find out what we need. So we are given that x equals 3 sine theta, which means sine theta would be x over 3. So that would be x over 3 as our opposite over hypotenuse. And then like before, this becomes 9 minus x squared. It's another way to just check to make sure that you're doing it all correct, that you've placed everything in the correct location. Now we need cotangent theta. And so that would become 9 minus x squared over x. But we're also going to need theta. So if you see that sine theta is x over 3, we immediately know that theta is going to be inverse sine of x over 3. And now we can plug those in and get our answer. So it's negative square root of 9 minus x squared over x minus inverse sine x over 3 plus c. And that's our final answer. So you can see it's the same process every single time. I recommend just looking, okay, we're minus x squared, so I need to replace that thing I'm subtracting for. It doesn't even matter what it is. I need to replace it with 9 sine squared theta. Factor out a 9. replace it with a cosine, and I get 3 cosine. So I just removed my radical and put a 3 cosine theta, and I can replace everything else now in the same way.